Okay. Velocity of particle p moving along the x-axis is given by the differentiable function v. We don't have v, though. We just have a table. And selected values of that velocity are shown in the table. Particle p is at the origin at time equals 0. X of 0 equals 0. So it starts at the origin. Okay, let's make sure we understand what's going on before we even read a question. Okay, x-axis, we're moving left to right. We don't have an equation, but we do have some values. And we also know that derivatives give us acceleration. Whoops, I've been doing that on this side. A derivative would give us acceleration. An antiderivative would give us position. All right, XVA, derivatives, antiderivatives. Part A. Justify why there must be. So this is what's called an existence theorem. Like something has to happen. It's usually the mean value theorem. Must be at least one time between 0.3 and 2.8. So 0.3 and 2.8, at which v prime, the acceleration, that was kind of them. They reminded us that the derivative of velocity is acceleration, equals 0. So I don't have a function to take a derivative of. Guys, can we put that away and focus on this? So it's telling me that v prime equals 0. And this looks like a mean value theorem type problem where the calculus slope equals the algebra slope. And I've got points, so points can lead me to an algebra slope. Calculus slope is v prime, so I think that's where we're headed. But if we want to use MVT, we have to say two things about v in order to use MVT. What are the two conditions? Do you remember? Differentiable is one. It's differentiable. How do we know it's differentiable? It says it. It says is a differentiable function. All right. So we still have to say, though, it's differentiable because you told me it was differentiable. What else has to be true? Continuous. How do I know it's continuous?
It's differentiable.
Because it's differentiable. Yes. Differentiability implies continuity, but not the other way around, right? Because you could have a sharp cusp that's continuous but not differentiable. But if it's differentiable, we know it's continuous. If it's both of those things, therefore, MVT applies. The mean value theorem. And the mean value theorem says that the calculus slope equals the algebra slope. The calculus slope, that's v prime. We don't really know that, but that's okay. We're trying to show that that equals 0. So let's use the points that it gave us. So 55 minus 55 over doesn't really matter at that point because you get 0 over something. So we're done with that one. The calculus slope equals 0 because of the mean value theorem. So that question wasn't really a position, velocity, acceleration question. That was more of a mean value theorem question. Part B. Use a trapezoidal sum, trapezoids, with 3 subintervals to approximate this interval. Remember, this interval, this means a lot of things right now. It means area under the curve. It means antiderivative. It means, in this particular problem, what's the antiderivative of velocity? Position. So it also means something about position, probably displacement. But it doesn't really ask me for any of that. It just says use a trapezoidal sum to approximate that. Okay, so maybe I need to remind myself what the area of a trapezoid is. It has a base, and it has 2 heights, so we use the average height. So base times average height. Okay, so base times average height from 0 to 2.8. Back up to my table. So yeah, I'll have 3 subintervals. Each of those subintervals has a width. And each of those has 2 heights. Usually, I feel like it either tells us to use the left height or the right height, but this time it's telling us to use the average of the heights, because it's a trapezoid. So, looking at my first interval, what's the width of that interval? Do you remember which of those numbers we used to get the width? How wide is that interval? Start picking on people then. Bailey, how wide is that interval? The first interval.
I guess 55.
This is sort of like the x, and this is sort of the y.
Oh, so that's 0.3.
Good. So the width is 0.3. So 0.3 times, and then I need the 2 heights. Zainab, what's the 2 heights of my first interval, or my first subinterval there? 0 and 55. And even though this is a calculator question, a safe stop is okay, so I think as soon as I write all these out, I'll be done. Alina, what's the width of my second interval?
1.7.
I want the width of it. It goes to 1.7, but how wide is it? It goes from 0.3 to 1.7.
Would it just be 1.4?
Good, so 1.4. So 1.4 is the width. Callie, how about what 2 heights am I using for that second interval? 55 and negative 29 over 2. Ethan, how about my third interval? How wide is it? 1.1. And Lauren, what 2 heights will I use for that third interval?
Negative 29, 55.
Good. Okay, and again, that's all it asks for, so I'm going to stop there. It doesn't ask me what that means. I don't need that any further that I know of, so I'm not going to put that in the calculator and risk messing something up. That's my answer. Part C, a second particle. Oh, they like to throw the second particle in there. Also moves along the x-axis, so that its velocity is given by this equation. Okay, I like equations because I feel like we can more easily go back and forth between position, velocity, acceleration. Find the time interval during which the velocity is at least 60 miles per hour. Find the distance traveled by the particle q during that interval when the velocity of the particle q is at least 60 miles an hour. So I need to know when that thing is more than 60. Well, I've got a calculator. So let's look at, get rid of all the old stuff. Let's graph that and see what we've got. 45 square root x cosine 0.063 x squared. It said 0 to 4 for my x window, so I'm going to go negative 1 to 5. My y window, I know I've got to get past 60 because I want to know when that thing is greater than 60, so I'll go 80, I guess, and see if that looks good enough. So there's my picture of velocity, and I would like to know when it's more than 60. So I can trace, and that can kind of get me sort of close, but I don't want to be sort of close. So do you know how I can figure out exactly when y is 60 on the graph? If yours looks different, it might be a different window. I went -1 to 5 and -10 to 80. Then make sure your equation is in there, right? 45 square root of x cosine 0.063 x squared. And if I want to know where that's more than 60, well, I can just graph 60. So now it's really easy to see that it's above 60 from there to there. But I need to know where those theirs are. Anytime you want to find something off the graph, it's second calc. So which one of those options looks like a good idea for this one? What are we looking for? Luca, which one of those options is a good choice for trying to figure out where my graph reaches 60? So I want to know that's where it goes greater than 60. I would like to know that spot. But that's not a 0. Zeros would be where it hits down here. Look at your options. Where it intersects. We haven't used intersect before, but press enter and it will walk you through the steps. First curve, question mark? We've only got 2, so this is not really a big deal. So I'll just press enter because I'm on Y1. Second curve, question mark? Y2, yes, that's what I want, so enter. And then guess. I've got 2 options here, and I'll just need to do both. So I'll guess the first one. So that first time is 1.866. Dot, 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 dot. I'll round later. And then see if you can find the second intersection. So do the same process and find that second intersection. .519. Okay, so V is greater than or equal to 60 on 1.866, comma 3.519. So there's my first part of that answer. Next question says, find the distance traveled. Okay, so distance travel. Andrew, how do I find distance traveled? Good, absolute value of V. But there's more to it. That's right, it's important to remember the absolute value, but what else is going on there? Well, the integral. Now, be careful. If you put, well, these are the 2 times we'll put. In fact, I'm going to kind of cheat this. I don't want to write those again, so I'm just going to call them A and B. Remember, that's completely legal. That way I don't have to write that again. That is the distance traveled from A to B. I don't have to put equals x of B minus x of A. That is the distance traveled. If you drop the absolute value bars, then you've got the displacement, which equals x of B minus x of A. But for total distance, I can put the absolute value bars on. Now, everything's positive from A to B, so this would be one spot where if you forgot the absolute value bars, it's not going to matter because it's all positive anyway. But let's do it the right way. Okay, now back up a second because I'm a little bit worried about these, about my rounding issue, because I rounded these, so when I go to do this, I don't know that this is going to be accurate to 3 decimals. I think it will be, but I want to make sure I'm right. So here's what we do to fix that. Let's see, second calc, intersection. get one of the guesses. It means I didn't have to do any of that. I just repeated all that. So the most recent thing in my calculator's mind is this 3.5191744. I don't really want to write that down. I mean, I could, but I want my calculator to remember that. So I'm going to go back to the main screen, and I just have to know that that's the most recent thing in my calculator's head. So if I go down to this STO button, store, and press it, it says answer into, and I want to call that one, that was B. I'm going to call that one B. And then sure enough, 3.519174428. But I don't have to write that down anymore. I've got that in as B. And I'm going to do the same thing for A. So I got to go find that intersection again. If I was paying attention, I guess I would have done this when I first found A. First curve, second curve, guess. So there's the 1.8661815. I don't want to write all those decimals down. I want my calculator to remember that value as A. And now my calculator knows A and B. This will make this interval, or this integral, excuse me, much easier. So math 9 from A to B. So I don't have to put in the weird decimals. The calculator knows A and B. Absolute value of y1 dx. And usually, that one was quick. Usually it takes absolute value a while, but that was quick. So 106.108. Nope, 109.
Can you do this on the graph too? Just like, or I got the same thing on the graph.
Yes, you can do it on the graph. I've not done integrating on the graph, but you can. Because you can integrate. The lower limit, can you just type in A?
Okay.
Yep. Upper limit B. And it even shows you, the nice thing about doing it on the graph is that it shows you what it's doing. So I hope you hadn't forgotten that it's area, but it's sort of reminding you that, hey, we just found the area under that curve.
Will that ever be wrong? Because we don't really type in the absolute value bars.
Okay, that's a great point. We didn't type in the absolute value bars. It was right for this one because everything was positive.
Mm-hmm.
So if there was negative stuff, it would not have worked. Shelby?
How do you get the absolute value bars?
Okay, so first of all, you don't get the absolute value bars on the graph. You can only do that if you're back on this screen. So math 9 is the integral A to B, and then absolute value bars are in the math menu, and num, math num, and then abs, and then you're ready to go. How many buttons can you push to finally get the antiderivative we're looking for? Part D. At time t equals 0, particle Q. Wait, this is a different particle. Particle Q. So x of 0 for particle Q is at negative 90. Using the result from part B and the function VQ from part C, approximate the distance between P and Q at 2.8. So I want particle P at 2.8 minus particle Q at 2.8. That's like where I'm headed. I want to know the distance between those two. By the way, another reminder that if you get half-ish of all the FRQs right, you're on pace for a 4. So hopefully you get some most of the way right, and some are harder and you only get 3 points, but most of them you get about half, you're fine. And that means you get something crazy like this, save it for the end and come back and try to get some points out of it. So I need x of p at 2.8, and I've got v of p, so that means I can integrate v of p from 0 to 2.8. Oops. That would give me x of 2.8 minus x of 0. That's what Andrew was getting at earlier. You put antiderivative position antiderivative velocity, you get position, and use those two limits. And we already, well, we didn't really calculate it. We found it. We didn't do the math on it. That was part B. So I made the big deal back at part B of saying, hey, I'm going to safe stop this because I don't need this. I need it now. So I'm going to go back to part B, figure out what that is. I mean, I guess I could leave it and just copy it all down, but I don't really want to do that. It's probably just easier to figure out what it is. .3 times 55 over 2 plus 1.4 times 55 minus 29 divided by 2 plus 1.1, 55 minus 29 divided by 2. So, kind of annoying, but hey, we got a calculator. So all of that is 40.75. Back to part D. So 40.75 equals x of 2.8. X of 0 they gave me. So that was like 20 minutes ago when we saw that. But x of 0 is 0. Okay, so now we know x of 2.8 is 40.75. For x of q, well, I have v of q. How do I get, Julius, how do I get from v to x? They gave me v, I want x. I want antiderivative v to get to x. And then I guess I'm using 0 and 2.8 again. Okay, so this is in the calculator. We found one of those, but that's not what we found. We found something else. So I'll need the calculator to find that again. X at 2.8 is what I'm looking for. X of 0 is negative 90. Right. Math 9. 0 to 2.8. That was y1. So, calculator, calculator, calculator. I didn't like that one. That's a lot of work. 135.938. And then move the 90 over. Minus 90. 45.938 is x of q. 45.938. So after all of that, I can subtract 40.75, and that's how far apart they are, 5.188. What a problem that last piece was. So that was a tricky one because it wasn't as straightforward as most of them. It had MBT thrown in there, it had trapezoids, tables versus equations. A lot of messy stuff in that one. Okay, perfect timing on this, I think. I want you to try number 11. It's a little more straightforward. You do get a calculator, but I feel like it's more straightforward. In fact, it was the easiest free response question from 2018. So you try number 11, and then I'll do number 11 in a moment. And by the way, these are supposed to take 15 minutes each. Okay. Distance will always be positive. That's one way to say it. Yeah, you want the distance to always be adding right? Even if you're walking backwards, you're still traveling. So this one is total distance. And we should probably say from 0 to 3.5. The other one is, what's the other word? Total displacement. Warren, what's up?
So how can you subtract it by 5 for B?
Okay, great question. How come I subtracted in part B but not in part C? Because I'm looking for a position, so I'm looking for x of 3, so I need to get that x3 and x0 in there. For part C, it didn't, it's true that this is equal to x of 3 minus x of 0. That's true, but I don't really need that because the whole chunk of stuff is the displacement. So displacement, I don't need to worry about plus and the minus stuff. And actual position, I do.
Please find interruption. Please release the pep rally. Officers and senators for Stuco. Dan, Marcy Cheer. Thank you so much. Have a wonderful day.
Part D, it gives me a second particle, but it asks when they have the same velocity, except it gave me its position. So be careful. I'll get its velocity, and then I just want to know where they intersect. Second calc, intersect. So V2 equals V at 1.571. So that part D was an easy one. If you recognize like what they gave you. So on these, you've got to be super careful about what they give you and what they ask. Right here, took a derivative to get velocity. They gave me position, but didn't ask me a question about velocity. All right, 18 multiple choice on Monday. 9 with calculator, 9 without.